this video, first thing we're going to do is recap. That's right, we're going to recap before we recap. So the three issues we're looking at here today is partial vertical collapse. That's the picture squishing a little bit. There's bad contrast issues, so we're going to look at that. And there's some broken buttons, primarily the auto color button on the front. So those are the three things you need to kind of investigate to see what the root cause of those is. As part of investigating and testing the tube, one of the capacitors straight fell off. So obviously that's going to be number one to be replaced, but there may be a few other bad capacitors that are also there that haven't been discovered yet. So we'll have to do some testing on the values of those capacitors, make a list of potential bad ones to be replaced, and hopefully that'll get us most of the way there. So check it out.
So back here, so the first step is we made sure that we discharge the tube here. So there's not a lot of room to work on these sets. We need to remove the anode here. And there's sort of this hook thing. It's really annoying to remove. Even though you discharge the tube, I try to really avoid touching the metallic part. It's just I suppose a precaution, but this is a fairly small tube, 12-inch, probably possibly less. It would definitely shock me if it was still full, but I have discharged the tube with this. We can do a double check and make sure that there is absolutely no charge left. If you feel paranoid, but generally don't follow idiots' advice on YouTube, and that means me. Do your own research, but yeah, there's absolutely zero voltage in here, so this is safe.
Underneath, it's a hyperalloy combat chassis, microprocessor controlled, fully armored, very tough.
So we're down to the easier wires to unhook. I'm doing this also to document the process, but I think we're not going to be able to clear the chassis out of this without needing to desolder some stuff. There are some easy things like this ground wire here, which is really just the ground wire for the tube. There we go. So we can unplug this. This is very critical to make sure that you plug it back in when you put this back together, because otherwise sparks will fly. Don't ask me why I know this. This usually stays together with the chassis, the neck board, because it is attached to the flyback, which is soldered to the chassis, and that's that. The yoke is now disconnected. Don't worry too much about the orientation. Usually it's a dummy plug, meaning you can only plug it one way, not the other, so you don't have to worry about that. The rest of the chassis, there's definitely a lot of dust here. Yeah, and this is where I think we may run into some issues here, because this is soldered to the board and it's not modular. This is probably the controls. Yeah, this is all the controls. We may be able to just unscrew this and take this as a one piece together with the chassis. So that's technically part of the chassis. Holy cow. That is a lot of cancer right there. Nicotine. It doesn't, I mean, my buddy was saying it smelled of old cigarette, but just, I don't know. It does smell funky though. That is a funky looking tube. Funky smelling TV.
No, I'm afraid I just blew myself.
Alright, so we're back. We got the chassis on the bench, desk, whatever you want to call that. So what we're gonna do right now is we're gonna try to find out the obvious problems. I cannot find a schematic for this set. However, it's usually TVs work on the same principle. There's always a power section, and then a horizontal section, a high voltage section, a vertical deflection thing, and then a color demodulation thing, and then a horizontal drive, and then a horizontal output transformer here. So it all works similar. We're going to concentrate here on the horizontal section, and earlier I showed that one of the cap here essentially popped out of the board with absolutely no resistance whatsoever, and it is baked, and it's definitely bad. This guy next to it is also bad, and these guys don't look especially enticing either. And so we're going to concentrate on probably these 1, 2, 3, 4, 5, 6, 7, 8 caps. We're not going to worry about this low voltage crap. I certainly hope that this isn't the problem, because these are impossible to find. Whatever the fuck that is, some kind of hybrid. The power section seems to just work, so we're not going to worry about that. Even though they might be slightly out of spec, we can test that later. Not going to worry about any of this stuff here. So we're just going to try to get to the main point here, which is there's an obvious failure here, and then this one's not looking good, and then these caps sort of have these weird the surround of it, the plastic is sort of unwrapping around it, so they seem like they've been bulging from underneath. So we'll replace this stuff, but first we need to find out what they are and write it down so we can buy them at the local electronics shop. Here we go. So that one was 4.7 microfarads at 250 volts. So we'll do that. 4.7. Come on. Okay, that's the first one. 4.7. That one here is, I can't tell. This is 3.3, 33 what? 160. These are high voltage. What else we got? The thing that you could do to sort of get your bearings on one of these chassis is always look for labels, and then the lines here are important. So like this section here, that's video CHR, which means chroma. So what this means is this chip's probably the video chroma decoder, which decodes the color and converts it to RGB so that it can be displayed on the tube. So that's a pretty low voltage section. I know this works because I did hook up something to it and it decodes it and it does provide some color. I think that is not the problem. So you can modularize sort of this when you troubleshoot and figure out, okay, well, that works. So, you know, the power obviously works or works well enough that it turns on. And the problem really is in the vertical section. So picture IF, PIF, picture IF, that's the tuner. This is like TV stuff. We don't really care. It maybe it works, maybe it doesn't. It's not going to affect the problem that we are having. This section here is not clear what it is. Can't see a label. Sound. So I'm guessing this is an audio amp of some sort. It seems to be working, so we're not going to worry about this section either. Okay, so then we come to, what is this? This is power still, and then yeah, this is part of the power section. Yeah, there's power right there. There's the Gauss coil here, and the power switch. I bet you the power cables here, obviously. So this is all the power supply section. Now, this section that's like over here, that's probably the horizontal and vertical, meaning that this is what controls because there's the yoke connector here. So this is what controls the sweep, both horizontally and when it go back up. So it goes, you know, it goes from left to right and then back again, and then it comes down and then it goes all the way back up and draws the next picture. So if I were to guess, this is probably the chip that takes care of the horizontal and vertical, because I'm not seeing any other chip on this board. That's the horizontal output transistor. So it needs a lot of power. This is a beefy high drive that just then drives pulses into the flyback and then just, you know, generate the big zappy kill you voltage. Don't touch that. So HA11423, HA11423. We'll have to look up the data sheet for this if we can find it. Yeah, so I'm guessing that this is the section that we want to concentrate on. So we put down for most of these, I think, the reference for all these caps, and this one looks pretty baked. And so this one, and this one looks okay. So we might just be lazy and not bother with this. I can't find an obvious vertical chip. On some TV you have one for horizontal and one for vertical. Maybe this one does both. I refer to this as the horizontal output transistor. It is not. It is a voltage controller to probably generate the B+ voltage, which then the flyback uses. Anyway, so that's a voltage controller. As far as I see, this is about it, and then I'm guessing this is a sound, and this is the chroma decoder. It's possible that this does the vertical, so HA11446. I doubt it, but we'll look at the data. The point is we got our list of capacitors, and then we went a second pass here and sort of figured out what are the common ones, so we don't order like individual capacitors. So, you know, sometimes you'll have something like at this 10 microfarad, there's a 16 volt one, and then there's a 25 volt one. Well, I'm not going to buy the 16 volt and a 25 volt separately. I'm just going to buy two 25 volt 10 microfarads and be done with it. It's just, you want to sort of reduce the amount of variation that you're going to buy, just so that you don't spend too long either online or at the store to get your caps. So this is my list. I went and actually did this the old-fashioned way. I went to an actual old-school electronics store, went shopping, and got my little brown bag of goodies. So we splurged. We splurged $4.99. quality caps. So what's interesting is obviously the stuff that I got from the store is a lot more modern than this 1986 vintage. So you can see this cap is a lot smaller. Same cap, 470, 200 volts, much smaller. Technology, yay. So that goes for pretty much everything we got here. This 4.7, 250 volts. This is the bad one, actually. This is probably the one that's going to fix the whole set. But as you can see, it is smaller. Same spec, much smaller. So that's the goody stuff. You know, do the boring, narrow it down, try to combine voltages. You can always go higher on the voltage. You should always stay at the same capacitance. If it needs a 220 microfarads, you need to just stick to that value. You can't get lower or higher. Get the same capacitance. The voltage, you can always go higher. Like this 50 volt, I could have gotten a 100 volt capacitor and it would have been fine. And it might actually be better because higher tolerance on voltage, stronger cap, it would probably last longer. But you know, again, we're just trying to get this TV going, so we're just going to get whatever spec was in there and trust that the engineers at Montgomery Ward did the right thing and spec their caps correctly, which, you know. So that's it. So that's for the caps. And again, another, you know, handy dandy little trick is you want to pay attention to the reference on the board. All the 400s look like they're the high voltage deflection caps, and all the 300s I believe are all for this color demodulations. And yes, I did confirm that this is a color demodulation chip. Basically it takes the signal from the RF, comes in here into the tuner, gets decoded into some sort of composite video, which then goes into this guy, and the NTSC composite video gets then decoded into RGB, which then gets sent to the board here, this thing, the RGB into the tube, and then it grabs the sync signal and sends it to the horizontal and vertical deflection here for the sweeping of the thing. And this is in fact the chip that takes care of both the horizontal and the vertical. Went onto the interwebs and pulled up the spec sheet, which is all in Japanese. HA 11423. We can see it here. Better light. It does take care of, it actually takes care of sync separation. That's probably coming from this, you know, the sync separation is important because this is what's going to do the timing. Horizontal drive here, H drive, and then this is the other section of the chip takes care of the vertical. So V-sync, vertical oscillation, vertical drive, vertical blanking. So this chip does take care of both the horizontal sweep and then the blanking, and just go back up for the vertical. So that's how it does it. So this chip does take care of both, and this is definitely the section that is of critical interest to us. So again, the first thing you do is, you know, turn it on, look at the picture and see what happens. So we saw two problems. So we saw the vertical squash, vertical just partially collapsed on the TV. And then on the left side of the TV, there was the sort of a darkness to the picture, and it was getting brighter. So, as I said, I don't have a schematic of this. I vaguely know what I'm doing. Mostly I don't. But there is a great resource online, TV FAQ, which I love because clearly that's someone who's been around the block a few times and probably knows what they're doing, and they have a bunch of scenarios for problems on TVs, common CRTs and monitors. And so what I do, because I'm an idiot and I don't really know everything there is to know about this stuff, is I look through these and find what matches my problem. And we are seeing a vertical squash issue. and then there's a little blurb about what to check. So this is a vertical deflection problem, possibly a bad capacitor, bad connection, flyback, pump up diode. So different things that I can check here. The bottom line is this is most likely either the IC is bad, or the caps, or some connection around it, or maybe the pump up diode. Anyway, we've got things to work on and look at. The next issue, which is I also found, and is interesting, is the left portion of the screen is dark or faded. Hey, look at that. This is actually kind of what we're seeing. And then there's a nice little quote here from a guy or person that had problem. I've got an old TV with where the left 1/3 of the screen is faded. It's especially noticeable when a dark picture is showing, like a nighttime scene. Well, it's similar to what we're dealing with. This is normally caused by a bad filter capacitor on the power supply line, typically 200 volts, that feeds the RGB output transistors. It is usually a scan-derived voltage off the flyback. Look for an electrolytic capacitor around 4.7 to 10 microfarads, 160 to 250 volts, fed from the rectifier diode of the supply. Well, that is uncanny, isn't it now? Because that bad cap that we're looking at here is precisely 4.7 microfarads, 250 volts. Take a look at the PCB. That cap's down here, or was down here, and then just popped itself out the PCB. Well, it's awfully close to the flyback. By the way, the flyback is this thing. Flyback thing, the zappy, ouchie, kill you voltage thing. Yeah. So anyway, it is located. If I can manage to get this thing. There we go. Maybe some better lighting would be nice. So we can see. Yes. Yeah, so that's the cap right here. You can see that the literally popped itself out of the soldering here. These are 2 holes here. This is where the cap was, C443. Hey, look, the positive side. This is the negative side in case you hooked up to the ground. That's fine. But the positive side is coming from a diode, which is itself connected directly to the flyback, which is awfully, or exactly what this says right here. Bad filter capacitor on the power supply line that feeds the RGB output transistor. It is usually a scan-derived voltage off the flyback. Look for an electrolytic of the same exact spec that we're having, fed from a rectifier diode on the supply. Flyback, rectifier diode, 4.7 microfarad at 250 volts. So I don't, sometimes I don't have this good of a match, but I highly recommend this TVFAC website if you are a hopeless amateur like I am. So most likely this jerk is 90% of our problems. Then we still have to deal with the vertical collapse. However, it doesn't look too bad, so I'm guessing we might get lucky and just replace one of the caps or just adjust the height on the pots. But yeah, this is probably our main problem. Well, I said that I was going to shotgun this, but we are going to do some testing here just to confirm that, mostly just so that I can confirm that I'm not going to need to replace all the caps. So I have an LCR meter here. There are many like it, but this is mine. I find it very convenient, and it came with this handy dandy little thing here, which is very convenient to test stuff in circuit. There we have it. 0.4 ohms of ESR and 410 microfarads of capacitance. Good enough. This is a 20% precision capacitor, so this is close enough, as they call it. But this little handy dandy thing is actually very nice to test things in circuits. By the way, yes, I did test this thing, and obviously it's bad. it just shows just 1500 nanofarads, which is it's just no good. And then the ESR is just horrendous, 1.2 kiloohms. So hey, surprise, surprise, this guy's bad. So now we can probably test this guy. Here's the 1000 microfarads, and then maybe a few around here, just to do a quick. Let's just make sure that we don't replace things that we don't need to replace, just to get the set going. All right. So what was it? 222 microfarads on the 1000. That's definitely low. But again, we're testing this in circuit, so this is not ideal. But this is telling us that this cap is definitely testing low, very, very low. I mean, this is not even within 20%. What else we got? C329. What was C329 again? Look at that. I actually did my homework, and C329 is supposed to be 6.8. Again, I'm doing 6.8. This is testing at 8.4 and then 7.2 ohms. Good enough. What else we got? C437. C437. That's 43 microfarads and 7.7. 437, 33 microfarads. Yes. This is all very, very. So anyway, this is boring. We're just gonna do one by one here. What is this? C334 is testing at 205 and 0.5 ohm ESR. That's pretty low. That's good. This is a healthy cap. 334, 220. Yeah, this is fine. C328. I mean, we're gonna do a few more here, but I mean, you get the point. 35 microfarads at 4.4 ohms. I mean, this is fine. C328. 30. This is 33. I mean, okay. This is in spec. So we're gonna just do a sweep here around all the caps that we're interested in, especially, well, actually there's this was the vertical horizontal chip here, and then there's a cap. Is it C3333? This is testing at 10 microfarads at 3.9. I can already tell this is probably fine. Yeah, look at that, 10 microfarads. So this cap's fine. It's fine, and it may not be fine, because obviously this is testing the caps at a low voltage, whereas some of these caps are subjects to much higher voltage. Also, I forgot to reset the frequency. Sometimes you do want to leave it in auto, because it'll adjust the testing frequency according to the capacitance, and that does matter. But the fact remains that this tests the cap at a low voltage. It does not stress the cap. So maybe when it's in the circuit at the rated voltage, the cap is actually not performing as it should. But this gives you a pretty good indication whether, I mean, obviously bad cap will test obviously bad, and they will not necessarily look obviously bad. So this does help and probably saves you a bit of time. And I just enjoy just using tools. So makes me look smart, I suppose. So yeah, very nice LCR meters, very good quality. I highly recommend it. And it comes with this, which is very practical.
So that's all the time we have today. As you saw, we tested the capacitors. We figured out which ones were wrong. We got replacements for those capacitors. And next time we'll show you those capacitors going into the device and do some additional investigation, because not all of our problems are going to be solved just by capacitors. There'll be some other things that we need to look at before we can solve the 3 problems we're trying to fix with this TV. So tune in next time, and remember, retro toilet, you flush it, we fix it. Turn your retro crap into retro gold. Please like and subscribe, and we'll see you next time.
All right, you know what? This was dumb. Dump it. Trash it. This was garbage.